Tencent Hunyuan just released this new paper. This is a benchmark, but we can use this exact same way to generate data, coding tasks for LLM to learn to reason, so synthetic coding reasoning data, as well as benchmark it automatically. So this could be like a good simulation environment where LLM just gets more and more generated coding tasks and learns, etc. What is Autocodebench? It's an automated system that creates programming challenges to test how well AI models can write code. Think of it as an automatic exam generator to test coding AI like ChatGPT, Claude, and other LLMs. It has 3,920 programming problems across 20 languages, fully automated creation, no human annotation needed. We can also use this probably to generate reasoning data, to teach AIs. So this is like generating synthetic data as well. So AIs can just learn in simulation and then become a lot better. Traditional code benchmarks like human eval are limited to simple problems, mostly Python focused, manually created, expensive and time consuming, become too easy for modern AI. So Autocodebench is using AI to generate its own tests, verified through automated execution in a sandbox environment. Key innovation: reverse order generation. Instead of creating a problem first and then a solution, AutoCodeGen works backwards. Start with a code solution, generate tests for that solution, create a problem description that matches. It makes perfect sense. This is probably a lot easier for AI. This ensures the problem, solution, and tests are perfectly aligned. So starting point in this workflow is real-world code snippets from GitHub via StackEdu dataset. So you can generate more tasks that are similar to these real-world tasks and then process in as I explained. So you can also just take raw code that's not even like tasks and then just use it as inspiration to generate tasks. This is similar to my last video where we generate synthetic text data based on the actual real data, not just without data, but we are rephrasing real data. This is better than just generating data without referencing real data. Then you can filter the problems. For example, you want to try to solve problem 10 times with some moderate model, and if it solves all 10 times correctly, that's too easy, so you can remove that too easy tasks. Other types of quality control using like R1 or some more capable model, Quen models are very good. Check that function names match problem description. No random non-deterministic behavior, test cases align with stated objectives, proper numerical precision handling, comprehensive test coverage. I think you can test all of this with the Quen 3 billion parameter or 4 billion parameter model, or maybe even smaller models. We want to make sure there are diverse tasks everywhere. So label problems by category, ensure balanced representation across programming paradigms, difficulty levels, real-world scenarios. For languages with limited resources, you can translate from Python to R, Ruby, Elixir, Julia, Swift, Racket. Java goes to Scala, Kotlin, C#, Dart, and all of this good stuff. So they're going to release these 3,920 problems in total, 20 programming languages, 200 problems per language, 37,000 test cases, average problem length for almost 500 characters. So you can generate more of these automatically for training a reasoning model, or even pre-training, because if you train on this data in the pre-training, it will also become better, and some companies are starting to use reasoning data in the pre-training as well. They tested different models. Claude Opus performs best, pass at 1 score, then Sonnet and O3 High, DeepSeek R1, and GPT 4.1. I guess GPT 5 would be maybe below Sonnet 4. It's around this range. So here even the best models struggle, which means the dataset here, or in benchmark in this case, is good. Reasoning mode helps significantly, of course, in coding and maths. this is on the path towards synthetic data generation. We're gonna have synthetic data. We're not gonna stay on human data forever. We're just gonna go on to synthetic, and we need to figure that out. You can use this to measure scaling laws. So pass at 1, accuracy here. We go number of parameters, going from 1.5 to 200 something. And we see that Qwen 3 series actually scale quite well. Then we have, but these are thinking series. And then orange is Qwen 3, blue is Qwen 2.5 coder, and the green is DeepSeek coder series. But they are older than these Qwen 3, so that's why Qwen 3 are better. You can also measure pass at k. So as we increase the number of tries to 10 in this case, then all of the models are gonna start passing, start giving at least one correct answer out of 10. Here we have overall performance of all of the LLMs. We got Grok 4 here. Of course, Opus and Sonnet are best. Gemini here, okay, DeepSeek. Kimi is actually quite high here. So is the thinking model, I'm guessing. And then Qwen, GLM 4.5. We got so many. Did you know that when models are scoring, LLMs are scoring, they like to favor their own outputs? They describe their methods in mitigating some biases. So that will be it for this video, and thank you for watching. Check out other videos on my channel, and see you next time.